who knows that this will come handy. Okay. Okay, QAs. First of all, let me apologize for today's online class. I hope you would not mind. Okay, our plan today, it's on chapter number 5, fundamentals of statistics, and see whether there are anything that any of you would like to ask or comment, yeah, or suggest. And then because we want to spare as much time as possible for chapter number 6 on variable control charts. Yeah? And Dr. Chong reminded me about this chapter 6 because it will provide important basics and fundamentals of control charts, because after midterm attribute control charts, so therefore we need to have good grounding on the tool of control charting. Okay. Can I ask whether or not everyone can hear me clearly?
Yes, sir.
Yes.
Okay, and then I also would like to request some interaction in whatever form, because it is very difficult actually to have online classes without much interaction. Yeah, so please help me so that we can benefit from today's class. Yeah. Okay. Quickly, the slides on topic number 5, fundamentals of statistics. Can I check with QA side whether you can see the slide or not? Or maybe QA is, can you see the slide? QA Hazrul, can you see the slide just now?
Yes, sir.
Okay, yeah. Okay, alhamdulillah. So let's go through quickly, because we have been doing some discussion and then some examples. So now we just want to go through to make sure that we did not miss anything. Yeah. If there's anything, so please stop me, because I'm not going to go through line by line. I'm just going to browse through and explain those that I think I may have missed, and then things that I feel require some reinforcement. Okay. So this is fundamental of statistics. Yeah? And then in this, make sure that we a number of basic information that we have to note, yeah, as we go along. And so these are very important in quality, yeah, in our quality works, yeah. Okay, so to explain, yeah, just to check whether we are on the same page, yeah, on the same page. So basically, we need to know what is frequency distribution, why it is important for quality works that we do, and then we already discussed in quite a detailed manner with some examples, yeah, the importance of central tendency and dispersion, yeah, dispersion. And then, of course, there are other measures that we are going to see, just to recap. And okay, we started to mention about the concept of population and sample, and then we discussed, and then we had a number of exercises on normal curve. And of course, we need to know some tests for normality and the diagram. So basically, these are the things that you or all of us must achieve, must know, must understand by the end of, say, today's class. Today's class. So all of you must know, must understand what is the difference between a variable and attribute. Yeah. So looking at things happening around us, and then looking at data that we collect, you and me collect. So we need to know whether this belong to variable or belong to attribute. Yeah, attribute. Okay. So if I ask QA Faisal, you know what we mean by a variable and attribute? Okay, mungkin QA Ikmal ke? Can you explain what is a variable and what is an attribute?
Variable is continuous.
Okay.
Attribute is what's the word?
If variable is continuous, attribute is, so the opposite of continuous. Kalau nak bergurau, say non-continuous lah kan. Kan? So the term that we use to describe satu, ya, continuous tu bersambung, ya. Kalau non-continuous tu kita kata discrete, satu-satu, ya, satu-satu. Okay, good, ya. Okay, so and then we'll see what we meant by this variable and attribute types, eh? Okay, and we also mentioned, in our exercise in class, we mentioned about the importance of significant figures, yeah. So I hope you remember that one. Yeah, number of decimal places, yeah. Those are important for our work in quality, yeah. So we don't simply collect data and then calculate those numbers and then simply write the answers without thinking, yeah, without thinking how those numbers are significant or not significant, yeah. Okay, and then there is also that we need to understand, yeah, and then use. Okay, of course, We don't expect everyone to use manual drawing of histogram. We can use software, yeah, to actually draw histograms, yeah, using Minitab, yeah, using Statistica, yeah, using Design Experts, yeah. All these are available in the internet, yeah, for you to do, yeah, using Excel. Yeah? But we need to understand what is a histogram, and then what can we use this tool for, and what we can learn from the analysis. And then, of course, at the end of today, we would be able to tell ourselves we understand what is central tendency, what is dispersion, and how they are related. Yeah. So that's, of course, I hope we also understand what sample. Yeah. And then by now, we should remember normal curve, yeah? And then the formula for standard normal value, yeah? Standard normal value, okay? And then, of course, we need to know there are what we call test of normality, yeah? Yeah, QA Zarif, kita ada test of normality, okay? We collect so many data for our quality works, okay? But it's important for us to test those data whether they follow normal distribution or not, yeah? Why? Because if they do not follow normal distribution, so we cannot use some of the quality tools, yeah, to analyze the data, because those tools assume. And lastly, then we must know and that a quality tool number 7 called scatter diagram is available, and then we must be able to use it. Yeah. So just to share with you QAs, when I was working in the company before, so my factory manager then, yeah, he was a Korean. He was very good, yeah, in using quality tools, yeah, on the daily basis, yeah, on the daily basis. He would stand near a machine and then observing the operators working, and then collecting data, yeah, values on the machine, values measured by quality people, and so on. And then he will of an envelope, yeah, so to speak, just to see relationship between two variables. Yeah? For example, the speed of the machine that the operators use, and the amount of rejects, yeah, of the products. Yeah, so he will do this quickly. Yeah, so he will stand by the machine. It will collect the information, and then he will, for example, draw the scatter diagram. Yeah, scatter diagram. Yeah, so he put all the points. Yeah, sorry, he put all the points, and then later on he will make a scatter diagram. So this could be cutting speed, and this could be percentage of rejects of paper. Okay, so that's what a good engineer would be doing. Yeah, would be doing. Okay. QA Syed, are you following me, inshallah?
Yes, sir.
Okay, yeah. Okay, so I hope you will you remember what we discussed in classes, and then the examples that we did and the discussion that we had together with these slides. So that will give you a good understanding of what we mentioned just now, the learning outcome. Okay, we are just going to go through, as mentioned, briefly, and then you should stop me if there's anything that you want to clarify or to comment. Okay, because I wouldn't see you, so I wouldn't know which one. We know that this is very important. We need to have fact-based, fact-based. So fact-based. So remember, this is very important to have what we call fact. Sorry, maybe that's no problem. I just want to say to just fact-based. Fact. This is very important even in our religion. Everything must be based on fact. On fact. So that's why it is very important for us to be statistically minded. So everything must be based on fact, numbers, not hearsay. Not hearsay. So very important. So I hope you understand. So that's the importance of statistics. To use as evidence of our quality of products and services. Okay, so when we have numbers, we collect numbers. These are statistics. For example, we have a number of products rejected. So that's statistics. Okay, the maximum speed of the cars that we produce, and those are statistics. Statistics also is the way we collect, the way we tabulate the numbers, and then the way we analyze those data, and then we interpret correctly those data, and then lastly we present those data to whoever needs them. Needs them. So as quality people, those numbers, and then we analyze using scatter diagram, using normal curves, using normality tests, and then we draw Pareto diagram, and then we analyze the outcome of this, for example, Pareto diagram, and then we make a conclusion, and then we present this to our boss, for example, to take action. Okay. So statistics, QAs, we can have descriptive statistics. If you go to Excel, you will notice that under data, you can select descriptive statistics. What is descriptive statistics? QA, for example, QA Naim. QA Naim. You know what is descriptive statistics? Or maybe QA Zarif ke? What do you know? What do you understand by descriptive statistics?
We collect an information, and we describe the we describe the characteristic of a product that we want to describe it by the information that we collect from the product.
Okay. Okay.
So I think that's it.
Okay. Let's say we have 100 items, your product, okay, 100 katalah shaft, shaft. And then you ask your quality inspector to measure the outer diameter of the shaft, yeah, because the outer quality, yeah, for our customers, yeah. So the length not so critical, the surface roughness is not so critical, yeah, but the diameter this time is critical to quality. We call it CTQ attribute, attribute. So your quality inspectors measure the outer diameter, and there are 100 numbers. Yeah, if only 100 numbers, maybe more, maybe more. If he collected maybe 3 times for each, then we will have 300 numbers, numbers. So as you mentioned, we can take an average for those 300 numbers. We can calculate standard deviation sigma x for the 300 numbers, yeah. We can also calculate, for example, the mode, mean calculated just now. So those few numbers mean standard deviation, total sum, yeah, and then mode, yeah, median. Those few numbers that actually describe the 300 numbers, yeah. So those numbers are what we call descriptive statistics. Boleh kan? Yeah, so we have 100 products. We collected data for the 100 products, and then we summarize the characteristics of the product using a few selected numbers like mean, standard deviation, mode, median, and so on. So those few numbers are what we call descriptive statistics. Yeah, okay. And then inferential statistic is that we have, for example, one lorry outside our factory. Our company bought, yeah, and then you ask your quality inspector to go and inspect the product. So I'm sure you agree with me, there will be no time for your quality inspector to inspect 1,000 items, yeah, yeah. This will take maybe a few days. Of course, the supplier will be angry. The lorry driver wants to go home, yeah, and do other things. So what your quality inspector would do by your instruction is to get some sample, maybe n equals 50, yeah, small n equals 50. So that's a sample, yeah, and equals 50, that's a sample. And then he actually tested 50 items out of 1,000 items, yeah. So based on the statistics, yeah, statistics, you already know what is the difference. We have some numbers related to samples, we call them statistics, yeah. So from this, your QC inspector will identify X bar and S, yeah, and these are statistics. And then he will provide these statistics to you, and then you as quality control engineer will test the hypothesis, and then also make decision, make some inference, yeah, and make some induction whether or not, yeah, the 1,000 parts on the lorry actually conform to the specification or not. Boleh agaknya? Boleh?
Boleh, sir.
Ya. QA Abdul Alim ada ke? QA Abdul Alim? Okay. So we move on, yeah. So attribute and then variable, variable. Attribute, as we mentioned just now, discrete. We count, yeah, say how many of the products are defective, yeah, How often are the machine repaired? Yeah, is it once a month? Is it once a year? So we are counting. Yeah, so these are counted data. Yeah, counted data. Okay. So just like we ask our quality control inspector to go down to the shop floor and then carry out inspection for the whole shift. Yeah? So record how many products are rejected compared to the total production. Yeah, so these are actually attribute data. Attribute data. So that includes number of defects, and number of defectives, and so on. Type of data is variable, and this is, as you mentioned just now, continuous, or measurable. Continuous or measurable. So we need an instrument like a vernier caliper, like a tensile testing machine, to measure the attributes, the attributes. Okay, so how long is our shaft? How long does it take to complete the task? By stopwatch. What is the weight of our product? So these are all variable data. Okay, so make sure you know this. Why QA site? Because at the end of the day, when we learn control charts, control charts, both in chapter 6 and chapter 9. So chapter 6 is about variable attribute control charts. So then, because of this understanding, we are able to select for our data that we collected, what charts are we going to use to monitor or to control the process? To control the process. So I hope, because our previous QAs, sometimes they use wrong charts in the exam. So therefore did not get any marks. Because from the beginning they did not understand, or they were careless in deciding what type of data were they working on. So for question on control chart, if you wrongly selected the chart, then everything after that would be wrong. Will be wrong. Okay. It's very important that we know this and we practice this. So when you write your answers in quiz, in assignment, in midterm, in projects, in end of semester exam, in final year report, as engineers, we have to make sure this. So remember, significant figures mean measured numbers. So if you report wrongly, not significant figures, then you would be fabricating numbers, numbers, and this is very bad as quality people, quality people. Okay, and remember, when we measure something, so there's always room for error. So that's why we always repeat. That's why we always repeat, because measurement is actually experiment. Experiment. So when we experiment, so always there would be some measurement. So always we must have repetition, like 3 or more. More. Of course, the more we repeat, the higher the cost. The higher the cost. The higher the cost. Okay, repetition because of error. So this is very serious. Sometimes our students, when they did their final year projects, they only took one measurement. So you can imagine if that particular one measurement was erroneous, was wrong for whatever reason, then the whole of your final year project will not be valid. So that's why for you, for us in quality, we understand that we must take at least, for example, 2 or 3 samples for us to take measurement. Okay, and then for example, produced by the American Society of Quality. So there are standards. If you want to measure something, depending on the size of the population, what is the minimum number of samples that we must test to give us the assurance, the assurance. Okay. Okay, Faisal, are you still with me? What about QA Hazrul? Are you still with me, QA Hazrul?
Yes.
Yeah, okay. So far, boleh what we discuss, is it okay?
Yes.
Okay, so important, very important. We want to see this when we have our quiz, special quiz and special assignment on Monday. So you must remember and practice this piece of knowledge. Them, go through them, and then make sure if anything ask in our WhatsApp group. So there are rules in using or reporting significant figures. So go through them. Okay, so I'm not going to go through them, not only because this is prerequisite for the course, and then we have learned this before. Okay, let's move on to precision and accuracy. Okay, so these are 2 concepts that we have to understand. Okay, so we take this picture here. So this is what we meant by precise. This means repeatable. So we can see that that we have this very closely means precision. But you know that this is not very good because this is far from the target. Here the average is on the target. The average is accurate, but most of the points are actually scattered. So they are not very precise. Of course, what we want is the third one, where those points, those data which represent our products, so they are not only repeatable and precise, they are also very close to the target, which is accurate. So I hope this concept can be understood. Okay, in describing data QAs, we have many tools. So the most basic one is actually frequency distribution. This frequency starting from whether the data belongs to variable type or belongs to attribute type. And then once you collect the data, we can actually collect individual points or individual value or number, or we can also put those numbers in a group, in a group. Here, group data. Okay, so we can use individual numbers or we can use group data. Okay, this is an example of frequency distribution. For example, blood type A, B, O, A, B. And then we collect the data of those people with class A blood type, and class B, and so on. And this 5, for example, is the frequency. So there are people in QC and so on. So this is a frequency distribution. Frequency distribution. Okay. Okay, so these are what we mentioned when we discussed Pareto that day. These are categorical data, categorical data. For example, grade in our course. Yeah? So A until F. So the grades for Manu 3313, this is also a categorical data. Data. Okay. Okay. So for ungroup data, for example, we have here example. This is for data that we can enumerate it. Yeah, for example, if we have the marks for the quiz, 0 to 10, so 0, 1, 2, 3, 4 until 10. Those are we enumerate, enumerate. So we don't group them into, let's say, 1 to 5, 6 to 10, but we enumerate individual data for that purpose. So that's ungroup. We do not group them yet. So for example, ungroup here. So we just collect the number of daily billing errors, billing errors. Okay. The bill, so we just collect those numbers or data. Okay. Let's see, we enumerate. We enumerate them. From 0 to 5, maximum number of defects on our bills. Let's say we work with AIS Selangor, and then we collect the frequencies, and then we just tabulate, So this is ungroup, ungroup. Okay. And then we can use tools like bar charts, and also this polygon, if I'm not mistaken, only the point rather than bars, to show our data, Okay, and of course we can do we can calculate frequencies relative, just like when we actually draw our Pareto, and see, we start to use probability here, or probabilities here, and also probabilities, or probability is part of statistics, statistics that we use in quality works, quality works. Okay. And of course, next we can actually group those data that we collect. So we collect. So these are the numbers. Steel ungroup. That we collect. This is the steel shaft weight that your quality inspectors actually measure or measured. And then after that we group them into groups of values, a group of so it's not easy for us to see any trends, anything useful from this. So if I ask you, what can we learn from this? So you see that it's very difficult to actually learn something from this quickly. Of course, maybe QA side would say, sir, why not we calculate some numbers? Yeah, and these numbers are what we call descriptive statistics just now. So if there are everything here, 110 of them, I think, so we can calculate, for example, mu, yeah, we can calculate mu, we can calculate standard deviation for 110, yeah, we can calculate the median, for example, the median, calculate sum, everything. So these numbers, as we understand, are descriptive statistics to describe these 110 items, yeah, items, okay? But we can also use frequency distribution and also histogram after that to help us see how our products are performing. Yeah. So these still not grouped according to certain classes. Yeah. Here these are everything. These are all the products or the measurement that we have. Yeah. This is coded from 2.500. Yeah. So 31 here would mean 2.531 and so on. Measurement, yeah, and then we continue to do this tally sheet, yeah. So this is what we call tally sheet, yeah. And then next we want to be able to do, for example, histogram. So these are some indication of or some rules or guidelines, yeah, for us to draw histogram. Yeah. So see the number of groups or cells. Yeah. If we have less than 100 observations, then we should have between 5 to 9 cells, cells or classes of values, If we have between 100 to 500, it is recommended for us to have between 8 to 17 cells or bars. 18 to 20 cells. Yeah. Okay. So, so these are guidelines. Guidelines. Of course, we can also calculate this. Yeah. Calculate the number of cells. Yeah. Number of cells, which is H, number of cells. Yeah. Cells equals to square root of n. Yeah. So if we have 100 observations on numbers, so number of cells should be around 10. Yeah, around 10. Yeah. Okay, that's another way of doing it. Okay, so what's shown in this few slides are the way for us to draw histogram. Yeah, histogram. Okay. QA Iman, are you following? Q Iman. QA Ikmal. Oh, QA Ikmal.
Yes.
Yeah. I request tadi kan kalau boleh at least once in a while tell me that you are still around with me. Yeah. Sorry. Okay. So you know range maximum minus minimum. So remember we talk about hey xi. Yeah? Remember we talk about xi. This is the individual value. Value. And we know this where we already discussed, yeah, in yeah, z equals to xi, yeah, xi minus mu, yeah. So I always try to repeat and repeat so that we know and we understand, yeah, yeah. Okay, so that's xi. So here we have range equals to x, the measurement, the highest one minus the lowest one, just to recap and then reinforce, enforce. So we find the numbers that your quality inspector collected, and then we see the highest one, and then we see the lowest one, and then we get the range, the range, okay, the range. And then after we got the range, so we want to determine the cell interval I, cell interval. So here we have one way of doing it, yeah, which is called Sturgis rule. So I, the interval between is given by R divided by 1 plus 3.322 log n, yeah, R, the range that we have determined just now. So n is the number of observations, yeah, the number of observations, yeah. So here we calculated the interval, the interval, and that interval is normally taken as odd, yeah, number, odd number. Okay, and then from there, knowing the interval, yeah, knowing the interval, so we work out according to the guideline just now, the number of cells, yeah, that would represent, yeah, the number of observations, yeah, the number of observations. Just now, I think we have 110 numbers observation. So from the intervals that yeah, on, for example, I equals 0.005, so that the number of cells, yeah, comes under the guideline, yeah, between around 100 or between 100 to 500, then this is actually 9 cells, 9 cells, 9 cells. Okay, then we determine the midpoints, midpoint. So we start by the lowest cell midpoint, yeah. So here, one way of doing midpoint, the lowest is the lowest or value plus I divided by 2. Yeah, here the guidelines that do not round the answer. Yeah, so I is 0.005, the interval divided by 2. This is the lowest value from our data. Yeah? And then we get the lowest midpoint. We just determine all the other midpoints by adding the lowest midpoint with the intervals, the intervals. Okay?
Sir.
Yeah.
So interval will only be one, right?
Interval will only be one, yes. Yes. Hazrul?
Yeah.
Here we have a number of intervals, possible intervals. Yeah. Remember just now we used Sturgis rule to calculate the interval. Yeah. So we calculate the interval, and then from experience, yeah, the interval value should be odd so that everything will be within the cell. Yeah. That's what we should remember. We want to make sure that no points will be on the boundary, yeah, on the boundary. So that's, and then we use the interval that we calculated, and then we play around with it so that we want to have the recommended number of cells, yeah, according to the total number of observations. Boleh?
Boleh sir.
Ya, boleh ya. Okay. Ini if you want to draw this manually lah. But of course we use Excel, we use Minitab. So we just tell the software that we have all these 100 data numbers, and then we want how many cells, yeah, and then the software would actually work out for you the histogram, yeah, the histogram. But this is just the understanding. Okay, and then of course after that we will go back to the collected data and we want to plot our histogram. Yeah, for example, with the midpoint and the lowest, lower and higher boundary, and then we have the frequencies, yeah, of occurrences, yeah, and then of course after that we would draw, yeah, our. So these are the boundary values, and these are the midpoints, and then of course after that we draw our histogram, yeah, histogram. So remember, we say that normally boundary values here have extra decimal place, so that all observed values will be within the cell, not on the boundary, not on the boundary. Okay, and then after that, of course, you plot your histogram. Yeah, plot your histogram. So this is the histogram of 100. Of course, if we have a software, then we can ask the software to approximate this using a normal curve. Yeah, normal curve. Okay, and then the software can also calculate for you the normality value. Yeah, whether or not this can be approximated with a normal curve. Yeah, normal curve. There are some statistics that software can calculate, yeah, for us to assume safely that this measurement of steel shaft weights can be modeled or can be assumed to be normally distributed. So here with this histogram, we can also actually put the mean or X bar. We can also put our USS. We can see how our product are performing. So for example, here we see that these are all non-conforming. Yeah, non-conforming. Okay, 6 of them. Yeah? And then if we take the fraction, so 6 out of 110, so we get some indication of the percentage of non-conforming product. Yeah. Okay, so a little bit more on this first set before we go and see the second set. So we want to just go through quickly so that the next class, of course, next class we have face-to-face special quiz and special assignment, which will cover this topic 5 also. So I want you to work hard to review, to do some exercise and so on, so that you achieve, alhamdulillah, achieving the learning outcome. Okay, so histogram describe variation. Variation. So of course these are variation. This shows variation in shaft weight. Steel shaft weight. So we can use this to help us solve problem. We can estimate process capability. Process capability. Remember we discussed on Monday 6 sigma X process capability. If we compare this versus USL minus LSL, we would know how our products, our process, whether it is capable or not capable, yeah, or not capable, okay? And then we can compare with specification. Of course, this is to the population. Is it one mode, yeah? Is it bimodal, yeah, bimodal, and so on, yeah, and so on. We can also see whether there are some data which are missing, yeah, with some problems, yeah, especially when your QC inspectors fabricate the data and then they did not do proper data collection. We can see some problems there in the histogram. Okay, so these are just various ways of illustrating graphically how the data look like. How the data look like. Okay, so this is what we mentioned just now, whether it is normal and symmetrical, roughly just now, whether it is skewed to the right. Yeah, so for cost assessment, normally we have skewed to the right. Yeah, skewed to the right. Yeah, or is it skewed? We mix our shaft just now from two suppliers, yeah, each supplier will have its own mean and standard deviation, so most likely we will see a bimodal distribution. Or is it leptokurtic, very high, narrow, or is it very flat? Yeah? These are the things that we can know. Okay, characteristic of frequency distribution graph. Yeah, we already discussed this a lot. Yeah, I hope you will try to remember and show your understanding. Yeah, location, central tendency. Yeah, and then spread. Yeah, variation, dispersion. Yeah, and then the shape. Yeah, the shape. So these are some of the things that I hope you would learn and show your understanding from this. From this, yeah. So I put in yellow here points that you should actually pay attention to. Okay, so this is the first set. Let us see whether there's anything that QA would like to actually ask or highlight. Let me just
Sir,
go back. Yeah.
frequency distribution graph, is it the same with normal curve?
Frequency distribution, actually, just now we say frequency distribution. If we group the data, QA has drawn, if we group the data properly, then when we draw the frequency distribution, it becomes histogram.
Oh,
Boleh?
yes.
And then, but of course, histogram is not the same as normal curve lah. Okay, because normal curve is continuous. Histogram boleh?
Dia terlekat jap tadi.
Oh, terlekat sekejap. Boleh tak ya? So histogram are bars.
Yeah.
Normal curve is actually continuous lah.
Yes.
Okay, so if we want a normal curve, then let's say we have 110. We don't draw histogram. We get the software to draw and model it as a normal curve rather than bars. So that's a normal curve lah. Yeah. Boleh ya?
Boleh.
Okay. QA Abdul Alim is not with us this morning. Ada ya? QA1 ada ke? One Fadli?
Ada, sir.
Ada?
Ada.
Ada ya? QA1?
Yes. Yes, sir.
saja tanya. Okay. So boleh kita proceed to the, ada soalan lagi tak? Okay, kalau tak ada, we go to the second set though. And see some of the things that which are important. There are so many slides, but because the slide, Dr. Chung has spread the thing nicely and with the examples, yeah. Jadi that's why it looks really long. It looks really long. But basically, here we are talking about the measures, the measures, central tendency, average, median, and mode. Itu semua kita dah belajar dulu. Yeah, depends on our data whether it is group or ungroup. Yeah, ungroup. I'm sure you know mean, mu, ataupun x. And then make sure you write properly. Yeah, write properly. Which one is mu? Which one is x bar? X bar. Make sure. Yeah. And of course, there's example here to remind ourselves how to do calculation of x bar. And make sure, for example, here number of significant figures, yeah, and decimal places, yeah, that shows measured value, yeah, measured value. So we cannot take the value from our calculator and put additional number, for example, 0 ke, 1 ke, whatever, because this is not true. Yeah, this resolution, yeah, additional numbers means that we have additional resolution in our instrument, which may not be true. Yeah, so make sure you write this properly. Yeah, we want to see this in our assessment. Data and group. So if we have group data, also we can calculate. Yeah, calculate. Okay. For example, here, this is example of group data. Yeah, in the first cell, midpoint 25, we have 4. Yeah, we have 4 items. Yeah, items. So we multiply the midpoint and the frequency, we get the value there. And we do the same thing for all, and then we sum it. Yeah, and then we can use the summation to calculate the average for group data using this formula of summation of frequency times individual, the midpoint, yeah, midpoint in this case, divided by the total number of observations, yeah, observations. So 11,000 sample, yeah, which is 320. So we get, yeah, we get the answer, yeah. 36.1, yeah, but this is in 1,000 kilometer, because this is tire, automotive tires, yeah, car tires. Our graduates, your seniors last time worked with Goodyear, yeah, with Continental tire, yeah. So these are some of the things. Okay, so this is average weighted. Average, yeah, average. So some example, yeah, some example here. To make sure you take a look at this. Median, we know median is the value that divides our observation into equal number of data below and above the value median. So we can have either ungrouped data or group. So we sort the numbers from the lowest to the highest, and then we find a value that divide the 10 numbers into exactly two halves. Yeah. So if we have an odd number, number of data, then the one in the middle, yeah, will be the median. But if you have an even number of data, then we have to take the average of the two middle values, middle values for ungrouped data, for ungrouped data. But for group data, we have to use the midpoint, and the frequency. So again, there are examples here that you can actually try to see and understand. So try and take a look at this one and make sure, and make sure. Of course, if there's any need for us to calculate, we do not want you to memorize anything at all. We'll give you the give you the formula. And of course, as you know, mode is the numbers that occurs with the greatest frequency. So it can be one mode, can be two modes, it can be multi-modes, and maybe no mode at all, because all the numbers occur with the same frequency, So, so a normal curve, if our data can be approximated with a normal curve, then we can see that the mean or the average will be the same as the median and the mode, Otherwise, we will have these situations where the mode so make sure and here we say that the average or the mean is the most common value that we use. We know. Just like range, and also standard deviation are the two most commonly used to measure dispersion, deviation. And then we have done some exercises, and then on this slides also we have examples. Let's see whether we can rush through in 10 minutes and complete these slides. So in addition to central tendency, where the center of our distribution or numbers that we collect, we also are deviation already. So we know range R, which equals to maximum minus minimum, maximum minus minimum, X max minus X mean, and then we already did some examples on standard deviation, and then we mentioned that we have two different standard deviation. We can have population standard deviation, and then we have sample standard deviation, sample standard deviation. So either this is sigma x, sigma x. We also have sample standard deviation S, and then we have variance here, which is sigma x square, which is population variance, S square, And we already mentioned what standard deviation is, which is the average, deviation from the mean, mean value. And then we already discussed a lot the importance or significance of these values, these values already, So here shows the sample standard deviation S, and the formula involve the individual value, minus the sample average, X bar, because this is sample, and divided by n minus 1, So, so make sure you take notes of this one, So there are example here We already talked here, and also we talked in our few classes on this. Yeah, few classes on this. Yeah, so make sure the units, QAs, the units. Yeah. Okay. So this is another way of calculating, but you can calculate using your scientific calculators in the exam. Yeah, so no formulas will be given there because you can actually calculate directly from your calculators. Yeah. So again, we have ungrouped data like this, or you can have group data. Yeah, group data. So these are group data. So example, group data example. Okay. So go through these slides carefully because we discussed in a number of classes already. Yeah, number of classes already. Yeah. And so we talk about this already in our classes. So go through them. And us in our WhatsApp group. WhatsApp group. So other measures include, we already saw just now, skewness. Yeah, how skewed is our distribution. Yeah, skewed, either skewed to the left or skewed to the right. Yeah, skewed to the right. Yeah, and then we also have kurtosis, whether our distribution is flat or is it peaked, yeah, like this, yeah, peaked. So that's a measure of peakedness, yeah, okay, peakedness. Also, we have the measurement of coefficient of variation, yeah, because we must give some perspective, yeah, and then we must, when we measure our standard deviation, yeah, we must compare this with our average, yeah, so that we can have some idea, yeah. So a standard small dispersion, if we compare this with the mean of 2,600 kilogram. But if we compare that deviation with 105 kilogram, so we know that deviation is really bad, yeah. So the quality is the dispersion is really bad, yeah. It's really bad. So that's what COV, yeah, indicates, yeah, indicates. Okay, so that's an example of the calculation of COV, yeah, coefficient of variation. So we talk about population and then sample. So I hope you understand. Yeah, I hope you understand. If we are talking about the population of Manu 3313 this semester, we have a total of 40 students, yeah, QAs. But if we take a sample, so maybe 10 for section number 1, so you will be the sample from the population. Talk about this one from the beginning of the semester already. Yeah, beginning of the semester already. Yeah, already. Okay, I just want to point out here. Yeah, so don't be confused with this. Actually, maybe some of the slides and then the textbook also, there are some errors, yeah, because they are not perfect. Here, when we talk about the central tendency for sample, we call it X bar or average. If it's for population, we call it mean, yeah. So here, either mu or X bar naught, yeah. So make sure it doesn't mean mu times X bar naught, yeah. So here, either we use mu, yeah, if we know the value, but if we do not know the value, we actually estimate the mean using the value of X bar. Similarly here for sample, yeah, S is a sample standard deviation, but for population, if we really know the value, so actually it's called sigma X, yeah, sigma X. But if we do not know, yeah, we do not know, we use, yeah, either S naught, yeah, estimated, or the best estimate of our sigma value, yeah. So this is not sigma times X naught, yeah. So either sigma or S naught, yeah, S naught. Okay, so these are just to explain and give examples of parameters and statistics, yeah. Statistics. And of course, the last one is normal curve. We already did some examples. We reviewed, yeah, the curve, yeah. So go through this slide, yeah, and some of the characteristics of the normal curve, yeah, normal curve, yeah. So and then there are examples, yeah. We already given by xi minus mu divided by sigma, yeah, sigma x, yeah. I hope you pay attention, yeah, keep aside, yeah, because either you know or you do not, yeah, and then you calculate correctly in the exam, yeah. So this is sigma x, yeah, for individual value. And we talk about this one already, yeah. And then under this, if you recall, so there will be 99.73% of the items under this curve, yeah? Standard normal curve, yeah? Standard normal curve. Okay? And this is the table that you will be using in the exam, yeah, in the midterm and so on. This will be given to you, yeah. And then I warn you that we don't have to give you both of these, yeah, for minus Z and for positive Z, because they are so this talks about the difference between central tendency and deviation or dispersion. Dispersion. We discussed about this in class already. Yeah, already. Okay, and these are the areas that we mentioned in class. Yeah, 68.26 or 0.3% of our products are expected to be within plus or minus 1 sigma, and then 95.46 are between plus or minus 2 sigma, and then plus or minus 3 sigma, would have 99.73%. So there will be a small portion outside plus 3 sigma and minus 3 sigma, 0.273%, yeah, 0.273%, yeah, would be outside the okay. Oh, sorry, so I will redo this one. Okay. Okay, that's the portion there. That's the portion there. So if you take a look at the table, you will notice that, yeah, at 3 point plus 3 sigma, yeah, so that will be if you calculate, if you minus, yeah, 1, you minus this value from 1, you will get that the portion, yeah, above 3 sigma would be 0.12, yeah, 35%, yeah, 5%. Okay, and then we can go to minus, oh, sorry, we can, and then if you do, sorry, so if you do this one, you will notice that, sorry, this is the other way. Below minus 3 sigma. Okay. Okay, so it's already 9:52. I'm not going to take any more of your time because you need to go to another class. So just to say that there are examples here, and then of course what we did not talk about is the test for normality. Yeah. So when we start our class, perhaps on next Wednesday, we'll just talk about this one before moving on to chapter chapter 6 on control charts. Yeah. Okay. So that's. Is there any question, QAs?
Sir,
Yeah.
so the quiz is until which part?
The quiz.
The quiz.
The quiz until everything. Formality.
Sorry, sir, I didn't get it.
Boleh?
I didn't get it, sir. Tadi start.
Lekat.
Lekat. Okay, lekat. So the quiz will be everything, topic 5, chapter 5 downwards, except for test for normality. Boleh? Lekat lagi?
Oh, sir.
Boleh?
Boleh. So
Yeah.
including the latest slide that you just explained, right?
Yes.
Okay.
Clear?
Thank you, sir.
Clear? Ada soalan lagi? Ada tak? Quickly, QA Faisal ada? QA Faisal ada? Tak ada? QA Azrul ada lagi tak?
Ada. Tak ada.
Okay, tak ada ya. QA Iman ada? Ada soalan tak? Mana pergi QA Iman?
Tak ada sir.
Tak ada ya. QA Ikmal ada?
Tak ada sir.
Tak ada ya. QA Iz ada tak? QA Iz? QA Naim ada?
Tak ada sir.
QA Zarif ada soalan tak? QA Syed ada lagi soalan?
No, sir.
QA Zulfadli?
No, sir.
Ya. Balik semula QA Zarif ke QA Naim? So prepare yourself for special quiz 1 and then special assignment 1 on Monday, yeah? Monday. So we come on Monday. First thing we have the quiz and then after that the assignment. Yeah? Okay. Wallahu a'lam. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Okay, sure. Ada soalan jangan lupa tanya dekat grup
Right, sir.
Thank you sir.
Okay.